Okay, so good day. Today we are going to discuss about finite geometric series. Okay, so if the given sequence or quantity is related to geometric sequence, then we'll be using the formula a sub n is equals to a sub 1 times the r to the power of n minus 1, wherein the a sub n is our last term, the a sub 1 as the first term, and r as the common ratio, and lastly the n as the number of terms. But if the given deals with the sum of the finite geometric sequence, then we'll be using S sub n is equals to a sub 1 times 1 minus r to the power of n all over 1 minus r, wherein S sub n is the sum of the finite geometric sequence, a sub n as the last term, a sub 1 as our first term, r as the common ratio, and n as the number of terms. Okay, so I have here an example. So given the information here, we're in a sub 1 is 3, our r is 2, while n is 5. So we are going to solve for the a sub n as well as the s sub n. So for a sub n, it deals with geometric sequence. So we are sure that this is geometric sequence since the given is a common ratio. So to solve for the a sub n, we'll be using the formula a sub n is equals to a sub 1 times r to the power of n minus 1. So all we have to do here is we are going to simply substitute the value of a sub 1, r, and the n. So we have here the a sub 1 is actually 3, the r is 2, while the n is 5. So first is we'll be solving the 5 minus 1, the exponent first. So 5 minus 1 is equals to 4. And then the 2 to the power of 4, that is equals to 16. So this will become 3 times 16, and 3 times 16 is equals to 48. So therefore, the last term of the sequence with information a sub 1, 3, r is 2, and n is 5 is equals to 48. What about the sum? Okay, so that is for the a sub n, the last term. What about the sum? What is the sum? So if we're going to solve for the sum of the geometric sequence, then we'll be using this formula. The s sub n is equals to the quotient of a sub 1 times the 1 minus r to the power of all over the 1 minus r. So same process, we are going to substitute the value of the given information. So we're in a sub 1 is 3, r is 2, and the n is 5. So this will become 3 times 1 minus 2 for our r, n as 5, all over 1 minus the r, which is 2. So first, what is 2 to the power of 5? 2 to the power of 5, that is multiplying 2 5 times, and that is equals to 32. And 1 minus 2 is negative 1. Okay, so you have there 32. So what is 1 minus 2? And that is negative 1. So 1 minus 32 is equal to negative 31. So from this given, negative 31 divided by negative 1, or we can also multiply 3 times the negative 31. So 3 times negative 31 is equals to negative 93 divided by negative 1. So thus our sign here will be cancelled. So our answer will be 93. So the total sum, or the sum of our geometric sequence, is actually equals to 93. Okay, so another example. Given the a sub 1 is 1 half, n is 7, and the last term is 32. So we need to solve for the r as well as the sum of the geometric sequence. So we are sure it is the sum of geometric sequence, as again our r, okay, the given here is r, the common ratio. So to solve for r, we'll be using the geometric sequence formula. So we will substitute the value for a sub n, the n, as well as the r. Sorry, not the r, actually, a sub 1, I mean. So you do have there, the a sub n is 32, the first term is 1 half, the n is 7. So what is 7 minus 1? 7 minus 1 is 6. So in this expression, for me to cancel the 1 half, I'm going to multiply it by 2. So 2 times 1 half is actually 1. So this can be cancelled out. So what is 2 times 32? 2 times 32 is 64. 2 times 1 half is 1. So it's okay not to write the 1 there. And you have there r to the power of 6. So next thing will be to cancel out the exponents of 6. So to cancel out the exponent, we are going to get the 6th root of the given equation. So now for the 6th root, you can now cancel 6. What is the 6th root of 64? The answer for the 6th root of 64 is actually 2, because if we're going to multiply 2 6 times, the result will be 64. So our r is equals to 2. Okay, now we do have the value for r, which is 2. And what about the sum? So using the sum of geometric sequence for finite sequence, so here we are going to substitute the value for the a sub 1, r, and the n, where a sub 1 is equals to 1 half, the r, which is 2, and the n is equals to 7. And for the denominator, substitute r by 2. So what is 2 to the power of 7? 2 to the power of 7 is 128. So multiplying 2 7 times is equals to 108. So in here, so 1 minus 128 is negative 127, and 1 minus 2 is negative 1. So negative 127 divided by negative 1, the sign will be cancelled out and it will turns to be positive. So the remaining equation now is 1 half of 127. So what is 1 half of 127? Or 127 over 2? So that is 63.5. So our answer will be 127 over 2, or 63.5. That is now the sum of the geometric sequence. Okay, so I have here another example. We are to find the sum of the first 5 terms of this sequence: 1 half, 2, 8, and 32. So if you have observed here, the given sequence is actually geometric sequence. So since we are going to solve for the sum, then we'll be using the formula S sub n is equals to a sub 1 times 1 minus r to the n all over 1 minus r. So first is we are going to identify first what are the given. Okay, so the given here from the expression or from the problem, our first term is 1 half. The r is 4, because that is 2 times 4. If we are going to multiply 2 by 4 is 8, and multiply 8 by 4 is equals to 32. So our r is 4, And the number of terms, since we are going to solve for the first 5 terms, our n will be equal to 5. So using the formula, substitute all the value or the given information. Okay, so your first term is 1/2. The r is 4, while the n is 5. Okay, so what is 4 to the power 5? 4 to the power 5 is 1024. And 1 minus 4 is equals to 3. And 1 minus 1024 is negative 1023. So as you have observed here, that the negative 1023 can be divided by the negative 3. So 1023 divided by negative 3 is 341. So what is 1/2 of 341? So that is 341 over 2, or simply 170.5. So that means if we are going to add the first 5 terms of this geometric sequence here is equal to 170.5. Okay, so thank you for listening, for watching. See you soon. God bless and goodbye.